Hello everyone. So this video is going to be talking about lab number 2, which will be due next week on Thursday, February 18th. So for this lab, you are going to be making what is called a star wheel, using these 2 pages at the end of the lab. Now, this is essentially a device that shows you what stars are visible in your sky at a given location on different days of the year, and how the visible constellations change throughout the year. So I have a bigger star wheel here to kind of give you a run through. I used this when I was first learning how to observe as an amateur astronomer. Of course, I later became a professional astronomer. But a star wheel consists of a wheel that you can turn, right? And there's going to be times along this outer axis, and you'll see dates along this axis, right? So, for instance, if I turn this so that today's date is currently February 9th, right? So if I turn this so that February 9th kind of lines up with 8 p.m., then this is going to show me what my sky would look like tonight at 8 p.m. Now, keep in mind, this shows the entire sky, right? So this is looking east, this is looking north, and this is looking west. Okay, so tonight at 8 p.m., these constellations that I can see here are going to be the ones that are visible in the sky. So as we look at the motions of the sky, there are 2 cycles that we see, right? So of course, one is the daily cycle as the Earth turns on its axis, right? So Earth turns on its axis through one rotation in 24 hours, right? So following today's date throughout the night, this runs from about 5 p.m. to 7 a.m., so roughly sunset to sunup, right? Following February 9th, at around midnight, our sky is going to look like this, right? So notice the motion of the constellation as we go through the night, right? We have stars that are rising in the east and setting in the west, right? And you might notice that these directions are backwards to what you would see on a map, right? That's because we're looking up, right? When you look down on a standard terrestrial map, you're essentially taking a view of top down, like you were in outer space looking down at the Earth, right? So since we are on Earth looking out toward the stars, that's why the directions are reversed east to west, right? But in the night skies, stars will appear to rise in the east and set in the west. So following my February night at about 6 a.m., just before sunset or just before sunrise, my sky is going to look like this, right? Let's go back again. Right, so at 6 p.m., Notice over here in the west, let's pick out one of these constellations and kind of follow it, right? Say Leo, the constellation Leo has just rose. As I go through the night, right, it's going across my sky. And then as I get toward dawn, Leo is going to be over here in the west, right? So it's traveled from the eastern side of the sky to the west overnight. Now the second cycle that we see is from the motion of the earth around the sun. So we're going to pretend like this is the sun, right? And as the earth travels around the sun at different times of the year, we are looking out toward the sky from different positions in our orbit, right? So say in, let's take our example again of what summer, right? So this summer, right, say at 8 p.m. on June 15th, we're getting near the summer solstice, right? This is what our sky is going to look like. So at this point, notice that, you know, whereas Leo was rising in the east a little while after dark in February, now just as it gets dark, Leo is over here in the west, right? And then as we progress through the night, Leo is going to set at about midnight, whereas it didn't set until dawn in February, right? So different constellations we see as more dominant in our sky in different seasons because we're looking at those out at the universe or out at the stars from different points in our orbit, right? So this changes our perspective of the background stars that we're seeing. So this lab, you're going to go through and you're going to answer some questions using the star wheel that you make, right? And so when you make this, you're going to take some scissors and cut out this inner loop, and then you'll cut out this. You're going to cut around this bottom part here so that this part folds up, right, to hold the wheel part after you get this cut out. But essentially, you're going to make the same thing as this big one that I'm showing you here, right? And you're going to use this to answer some questions. All right, one of the first questions asks about circumpolar constellations. Now, hopefully you know from your reading what circumpolar constellations are, but I'll demonstrate, right? So again, let's go back to what we're going to see tonight. All right, so at about 7 p.m., this is what our sky is going to look like, right? And as we travel through the night and go till about dawn, notice that these constellations out here are rising and then setting. Setting is going behind this part. Think of that as your horizon line, right? But notice that these stars or these constellations kind of here in this area never go behind the horizon, right? So they never set. these are what are called circumpolar stars, right? So if we think of our north celestial pole as being the 0 point, right? As we move outward, um, anything that is within 37 degrees, essentially, that will fall into this circle, is going to be circumpolar, right? And so this lines up with our latitude. So here near Bowling Green, we are about 37 degrees north latitude. So that means that constellations in the sky within an altitude of 37 degrees are going to be circumpolar. All right, so you're looking for the constellations that never go behind the horizon as the Earth rotates and as we rotate throughout our orbit. So you're going to go through and answer these questions. There's one more question that I want to hit. So this number 3, about what fraction of a circle do the stars move in 1 hour? Okay. So I want to give you a hint here, right? So we said there's 2 cycles, right? At 8 p.m. tonight, right? This is what our sky is going to look like, right? Here's Pegasus, like this point, just setting in the west at 8 p.m., right? If we turn through one complete cycle, this represents 24 hours. So we're turning counterclockwise here until we get back around to February 9th at 8 p.m., right? So notice the stars are going to look roughly the same tomorrow night, right? So that means that it makes one cycle in 24 hours, right? So in 1 hour, how far would the stars appear to move, right? So you're essentially dividing 1 by 24 here, right? The second part asks for part B in 1 month, right? So we also go through this same cycle in a year. So in 12 months, there's going to be another complete cycle, right? And so in 1 month divided by 12 months in a year is going to give us the fraction of a circle that the stars move with respect to us in 1 month. All right, and then there's some more questions that you will go through and use your star wheel to answer. I'm going to one place. When you get ready to turn this in, if you navigate to where you found the lab, right, this is in chapter 2. I'm trying to keep these within the weeks that I post them. So if you go back here where you downloaded the instructions, if you click on this, it brings up what is a little, like a little quiz, right? So the questions that are on this are the same questions that are here in the lab, right? So you can work through them using the document, right? But the same questions are here in this little quiz, the exact same questions. So once you work through it, you can come back here and just select your answers, right? You will have to upload an image of your star wheel that you created, right? So you can take a picture with your camera, and this is where you will upload that file, right? And you can save this and go back to it later, right? So this is a little different. Instead of completing them on the document, you will actually come in here and select your answers to the questions in Blackboard. This means that it will be graded quicker. Okay. All right. So that's all for lab number 2. Hopefully that will help you understand what to do for that one. I will post a short video instructions on the next lab within the next couple of days. It's going to be an observation lab, and it will take you quite a bit of time to do because it involves observing the moon for a period of 2 weeks. All right, but more on that in the next video.